Let's do another counting problem. This time let's count how many four-letter words there are using lowercase English letter consonants, including Y, that include exactly one occurrence of B. So exactly one B. Now we've got four positions here, four letters we're going to put together, and one of them has to be a B. And we're going to organize our steps to create this word by first picking where to put the B. So our first slot will not regard the first or leftmost letter. It will be pick a position for B. And there are four places in which to put it. So there are four ways to complete that step. Now the next three steps, I'll describe them together. So let's pick a letter for each remaining position. We don't know which positions they are. They're not necessarily the last three. Depends on where the B is. But they cannot be B. So there will be 20 other consonants. 21 total, and the B has been used and cannot be used again because there's only one of those. So the other three places filled by any of the other consonants would be 20 choices each, and that's 32,000. So that's 32,000 words. Okay, so that's a different organization here, but it suits the thing we're trying to count. Now let's talk about strings. A string is a more general word than what we've been calling a word. A string of objects is a linearly ordered arrangement of the objects. And that means that because there's no specification otherwise, the objects can be repeated. So there may be several occurrences of the same object. Unless we say otherwise, unless we specify otherwise. So the words above were strings, and another type of string is a bit string, and a bit string is simply a string of bits, and bits are 0 and 1s. So in particular, here's an example of bits of a string of length 3 of bits, a bit string of length 3. So our first question that regards strings is how many strings of 6 lowercase English letters are there total? And because there's no specification here, we understand that that means that they can be repeated. So what I'm going to do in this case here is do a straightforward listing of the slots according to the position. So this be the first in the left, starting from the left, and there are 26 English letters, and the second, because repetition is allowed here, would be 26 as well, and the third and the fourth and the fifth and the sixth as well. So the answer in succinct form is 26 to the 6 strings. Okay. Now we want to do the same thing without repetition. That means that a letter may appear at most once in the whole string, and so the things that we're going to do here are very similar. Certainly there are 26 choices if we start from the left and work to the right. You may have said, hey, I don't want to do it that way. I'll start from the right and work to the left. You get the same thing, but this is a natural way to do it, the way we read left to right. So the first letter, and there are 26 choices. Remember, that's what this number represents, the number of ways we can do it, 26 choices in this case. And then there are 25 for the second one, and then there are 24 and so forth. So that product right there is the number of words. Strings. and that would be without repetition. 3 is not much harder here. 3 asks how many such strings there are without an A appearing anywhere. Well, there's 25 of the letters other than A, and so this is very much like the first one, because I'm suggesting we allow repetition here, except now there are 25 choices for each of the letters, and because it's repetition, then each spot has exactly the same number remaining to choose from. So 25 to the 6th power, again the first one, second choice, etc., in that order. So we have this number of strings. Excuse me. Finally, the last one here asks how many of these strings of 6 lowercase English letters have at least one A. The thing to avoid is somehow double counting or not understanding what a step involves. And so, I know some might start this and say, well, is it 6 times 26 to the 5th? And the answer is no, because it's not clear at all. What is this step? What is this step? Because if there's more than one A, it's not legitimate to say pick a slot for the A, because in that way we may be double counting, because if there's more than one A, then there's different ways to start this by picking a slot for an A. So the way that is best done here, there are many ways, but the way where this is best done, or how this is best done, is to say take the total number of strings, which is 26 to the 6th. This is the total, and subtract from that those that have no A. And that will be the number, this is the number of strings with at least one A, and I will call this complement thinking, because we're removing the complement from the total to get the part that we really want. All right, we'll stop there.